guess we got 16 seconds to wait. Maybe we'll get started. Hey there, I'm Brendan.
I'm George.
Yes. We're going to talk about how you can scale and secure and optimize the Azure Kubernetes Service. Yeah, thanks for coming and hanging out with us. All right. I got the clicker. All right, I'm driving. So I wanted to start by looking at sort of why we're here. So how many of you used Kubernetes 1.0? Anybody out there? See a couple hands? Did it work for you? Hopefully, maybe. So 10 years ago, we started down on this journey, and a lot of the reason why we started down on this journey was at the time, deploying applications was just too hard. The state of the art were tools like Puppet or Chef, Salt, if you were lucky, maybe Ansible. And they were all imperative, and they didn't have self-healing qualities to them. They didn't have this notion of taking away any toil other than just kind of getting stuff onto disk, right? And in fact, the way that they put things onto those machines was itself not very atomic. And I think it's sort of unimaginable to think back into the past and think about how much harder it was to say to somebody, hey, just deploy this application that I've built out onto a distributed system, out onto a cloud infrastructure. Then we've come a tremendous way in terms of getting everybody onto declarative infrastructure where you can say, this is what I want. I want there to be 3 replicas, or even I want this thing to auto-scale in response to load, or in response to people uploading files, or in response to really anything that you care about. We've come a very long way in creating this amazing ecosystem of tools that run on top of this clustering and orchestration infrastructure, and we've really dramatically simplified how people can think about building and deploying their applications. But we're not done, and the reason we're not done is twofold. I think the first is that all of that work in developing that shared infrastructure powered the AI revolution that we're seeing today. I was on a talk yesterday with Eric Boyd, and I actually joked that I didn't think that AI particularly cared very much about Kubernetes. And he said, no, we care about it a lot because you take care of a lot of the problems that we don't want to think about, right? Which is all of the machine management, all of the scheduling, all of the redundancy and replication. And so everything that you see in every AI demo, I suspect, that you've seen at this conference is running on top of that infrastructure that's managing these very, very large-scale training jobs, or even the inference serving that we're doing. And in fact, within the Azure Kubernetes Service, we're both really happy to be able to provide that service to teams like Azure ML and to the OpenAI team and many more, but also to get involved with things like the 𝗦𝗲𝗀 open source project for doing AI easily in a Kubernetes-centric way on top of your clusters. And so AI, I think, has really been this amazing demonstration of the power of container orchestration and container technology to simplify the world for another application, in this case, all of that AI. They didn't have to worry about all of this stuff. They got to just start with a distributed system orchestration system, build out everything that they did. And I think we're a lot farther along in AI as a result, much more consolidated around certain infrastructure. But I also am sort of regretful, I would say, about the previous 10 years, because when I look back, one of the things that we were trying to do was make it easier to build these distributed systems. And though I think we've provided a lot of infrastructure that's useful for building distributed systems, I don't think that we've materially made it easier for the developer to build reliable distributed systems. And that's why I'm particularly excited about this growth of platform engineering, which I think is actually going to maybe turn the crank on making it easier for people to go and build things that developers can adopt in the same way that you build an app for a smartphone, or you built an app for Windows or Mac OS. So I'm hopeful that as we move forward into the next decade of Kubernetes, that that sort of platform is truly going to coalesce around developer and developer productivity. Now, for those modern applications, I wanted to go through all of the capabilities that AKS provides, and we're going to deep dive into all of these sorts of things. Obviously, I think the first thing that most people come to us for is managed operations, just making it easier. But also, we're doing a lot of work lately on developer productivity, building bridges to VS Code and to GitHub. And then finally, of course, Azure is a worldwide cloud, and one of the amazing benefits of being out on the Kubernetes service is that it makes it easy for you to port your application, or even to do things like have your workload follow the sun so that you can have access to green energy around the world. But of course, we're also bringing in things like auto-scaling and other kinds of cost optimization, simplifying your life in security with automatic patching and upgrades, understanding what the heck's going on, more importantly, when your application isn't working right. I think we spend a lot of time in these conferences celebrating how our applications work well, but we also want to help you when they don't work well. And then, of course, there's been a tremendous focus within Microsoft and Azure over the last year on security, on resilience, on zonal resilience. And then finally, I just came off from KubeCon last week, and being immersed in that open source community and a bunch of the great announcements we had there, like Hyperlight, and a bunch of other things that are available for anyone, anywhere, not even on Azure, not even a customer, to run. And to see how all this comes together, we have a great video here from our partners at BMW, who are going to celebrate how they use the Kubernetes service. I hope this plays. There we go.
BMWs are built with quality and reliability that people trust.
Our engineers integrate every car with cutting-edge digital features to help keep drivers safe on the road, while delivering world-class performance. Testing of all functions plays an important role.
In the past, we used hard drives in our development cars to store test data. Developers had to wait at least a day to get fresh data for analysis. We built a mobile data recorder that's integrated into the car's digital nervous system. This IoT device transmits data in real time.
For our time series analytics, Azure Data Explorer was the only way to go.
Now, engineers can chat with the interface using natural language through Azure OpenAI Service. The MDR Copilot's front-end and back-end are managed by Azure Kubernetes Service. Azure Database for Postgres stores Copilot conversations and feedback. Azure is the turbocharger for delivering the right data to the right person on a large scale.
Data analysis went from days to minutes, with speeding time to market even as the number of features increases dramatically.
MDR, powered by Microsoft Azure, ensures BMW reliability and quality long before the cars hit the road.
All right, super cool. So I think it's really awesome how we're seeing BMW do that. And we're really about enabling you to do more with Kubernetes, just like BMW did, both by providing innovation in the open source communities and also providing the Azure Scale ecosystem and management that you expect. And we have all of these different pieces of the Azure Kubernetes service, from elastic capability or elastic capacity, performance and scale, as well as security and developer productivity. And to give you a deeper dive onto that, I'm going to ask George to take over, and he will focus on these ones here.
Yeah. So today we're going to focus on three specific ones, which are proactive workload resiliency and simplifying operations to achieve that. We're going to be focusing on how we're working to make all that security work that Brendan mentioned more effortless, so that you are very easily able to consume it and not just have all the controls available to you, but also have them built in, have them default, and have them have a very simple experience. Finally, we're going to talk a bit about optimizing, namely through cost, and some of the things that we've been working on to help with that. I'm sure that a lot of you might be interested in some other topics from that wheel that we're working on right now and for the future. And so, as Brendan mentioned, we just came out of KubeCon last week. So on that kind of left-hand side, you have a QR code on aka.ms/AKS/KubeCon NA 2024. Those are the recordings from last week. And also in a couple of weeks, we will be presenting KubeCon in India for the first time. And we'll also touch on the remainder ones, namely development and AI. We'll have a lot of focus there. So let's focus on these three today. The first one is proactive workload resiliency. And the way that we think about it has really these three areas. One is providing you with a platform that is reliable, that has all the right infrastructure SLAs, that has all the right constructs from zone availability to global availability, and that allows you to have all operations, all components fully managed by us. The second is how we help you achieve application resiliency, be it by providing you with the right deployment configurations, providing you with the right monitoring controls and features, or providing you with services like chaos testing or backup as well. And finally, one of the key issues that we hear a lot still in Kubernetes, even after 10 years, is the struggles with upgrades. And so we've been doing a lot of work in that area, and we're going to be discussing some of it today, as well as recapping some of it. So first, I want to briefly introduce, for those of you that might not know about it, AKS Automatic. That's really the wrapper around all these three areas for us right now. Automatic is a new SKU of AKS that allows you to basically get from code to production in Kubernetes in minutes by leveraging all the tools that we have with AKS and also providing you with a platform that is, again, 100% AKS, but fully managed and fully guardrailed for you or your application teams. Today, we're announcing the dynamic system no pool capability, which further enhance our management of the system components and allows you to really focus exclusively almost in your workloads only. And as we shift to workloads and into applications, one of the key areas that are particularly tricky is ensuring that you have the right application monitoring. And so we partner with our application insights and Azure Monitor teams, and we're really happy to announce the Outer instrumentation with application insights, which allows you to have, for all of your workloads, a very simple way to instrument them, to get traces from them, the number of requests, the latency of those requests, error rates, and much more, and doing so without any code changes. You don't have to go and rework your applications, rework your code, add SDKs, and do all those things that in the past you had to do and were already available to you. You can do that by leveraging the OpenTelemetry distro from Application Insights that does that and allows you to instrument it, be it by deployment or by namespace altogether. Keen to take a look? So let's see how this actually works. And in order to do so, we'll be using an application. You can actually check it yourself in that repo that is absolutely not containerized. It's a simple mock of a flight purchasing website that has a backend in Cosmos DB with a Mongo API. And so we're going to deploy everything from scratch, and we're going to add those application insights integration and that auto instrumentation that we're announcing. So in order to do that, we'll be using Draft, our open source bootstrapping tool that in the portal we call automated deployments for its UI, that immediately allows us to say, hey, I have a repo, which is my Contoso Air repo, and I want to containerize the code that is there and deploy it to a new AKS cluster in this case. So the only thing we need to do in order to achieve that is pass on our repo, select the specific branch that we want, and from here we can either load in our existing Docker files or auto-generate one, which is exactly what we're going to do. So we're going to auto-generate a Docker file since there's nothing in this repo. And it automatically detects that it's Node.js, that it's exposing port 3000, and we just pass on our source code directory, and from there we just define where we want it to land, which registry it's going to go, and what's the image name that we're going to define for it. Moreover, there's no Kubernetes knowledge in that repo per se, so we're going to automatically generate the manifests. In this case, it's going to be a simple deployment and service, but we also generate things like ingresses, scalars, and much more, PDBs, everything else. And Draft does all of these deployment manifests following best practices. So they all have probes, they all have PDBs, and all the necessary constructs that you require for high availability and workload resiliency of this application. So the only thing we need to basically say is give it the name for the namespace where we're going to land this, or it will be automatically generated. And you see right away that multiple alerts and default metrics are already being captured by these applications leveraging Azure Monitor, Managed Prometheus, and Grafana. So once this is done, usually this is where demos apply stuff directly, imperatively. That's not something we like to do or recommend. So what actually Draft and automated deployments does is it submits a PR back to the repo that you configured, and this PR has all these files that were automatically created for you, and also has a pipeline generated for you. So you can do GitHub Actions, you can do ADO pipelines, and much more, including GitOps like Argo and Flux are things that you can leverage here. And once you merge that PR, you're going to trigger that workflow that we automatically generated for you, and that's going to deploy all of these components to the cluster. So once we're happy with this, we're now able to go check our application. So we can navigate to the cluster that was created by this flow, which is our Contoso Air cluster. And the one thing it needs, as I mentioned, is a backend. So in order to add that backend, I pre-created a Cosmos DB. But this is where now usually a struggle comes in from a developer perspective and operation, which is how to connect securely that database. So Service Connector allows you to do that. So we just select the Cosmos DB that we have pre-created. We define how we want to connect to it, which we're going to use workload identity, which is going to ask us for an identity. It's going to establish a trust to this cluster, and this identity will have the right permissions to access this Cosmos DB. But usually this is where it gets a bit tricky, because now you need to basically load and pass on to the workload this identity that you establish trust with via a service account, and then load some environment variables, typically via a secret, for example. This might be a bit foreign to this handoff process between maybe developers and operations. And so Service Connector helps with that by, one, establishing the connection, getting all the endpoints and connection strings, and then helping you load that service account, create that service account, and load it to the deployment. So you can just select your deployment, which is that 𝗦𝗲𝗀𝗶𝗀𝗃 that we just created via draft. We just select it here, and it will tell you, you can now decide how you want to do this. You can copy-paste exactly what it referenced right here, which is the service account, it's using workload identity annotation, and the secret with all the environment variables. Or you can actually apply it and let us do that for you like we did before for the deployments, and we'll load that into. So once this is done, we now have our front end and back end ready to access, and we can just navigate to it just to see that it's up and running and working. And there we go. This is our 𝗦𝗲𝗀𝗃. Now, the thing that we really wanted to see, right, was where are my traces and how easy it is to get those going. So the only thing we need to do is that enable Azure Monitor app monitoring. This will enable the add-on that will then expose these metrics and send them. The second thing you then need to do is get a connection string for the instrumentation key for application insights. And the place you load this is into this instrumentation CRD that you're going to deploy in the namespace you want to be automatically instrumented. So in our case, it's our 𝗦𝗲𝗀𝗃. You can now deploy different namespaces to different app insights, total granularity for you. And in that CRD, as you just saw, we were specifically selecting node. So now we're going to restart our 𝗦𝗲𝗀𝗃 to take on this new automatic instrumentation. And you'll notice that now there's two containers. And those two containers, one is our image, of course, and the second is our OpenTelemetry distro, doing all that work to automatically instrument and get us all those nice traces. So once we now go back into our app and start doing just using it, again, we've done no code changes, nothing to the app whatsoever. So we can just book a trip, for example, a round trip between hopefully warmer places than here in Chicago today. And once we do this and complete our operation, let's go next. Those are decent prices, I assume. And once we purchase, we can now go back into our portal, navigate into application insights, and into our application map. And from there, you're going to see a big picture of what your application looks like, where it's connecting all the different endpoints, and see the kind of traces that you typically expect with the different time it takes for all the calls, what's the longest call that is made. And you can even leverage those insights to investigate performance issues, improve your performance, check where the connections are going, how many calls are being made, and much, much more. So that's your application now instrumented. What about upgrades? The usual struggle that we hear from all of you about upgrades is stay within a supported version is tricky. Performing successful upgrade windows altogether is kind of cumbersome and sometimes hard to do. The rate of success is not that high because it stops a lot of time conservatively to ensure no disruption. But then if things are always stopping, it can take some time. And then if that doesn't happen, again, there's no availability constraints or some other reason, there can actually be disruption in our workloads. So what are the reasons for this to happen? One is availability constraints misconfiguration, like pod disruption budgets. Over 70% of all our issues of upgrades that get canceled by the platform are due to this one reason. The second is just none whatsoever. So you have PDBs, but maybe you don't have probes, or you have probes but no PDBs, neither. You don't have extra capacity when you're upgrading, and this can generate problems when you're doing that upgrade. The third is a very common one, and it was actually one of the main causes before we actually attacked it, which is Kubernetes API breaking changes. Which is, in Kubernetes, when you do the upgrade, the objects get automatically changed within etcd, but things like operators, client tools, applications that are leveraging Kubernetes APIs, those are in code, and they might not be automatically updated. So that was a big problem when you upgrade to a new region, and that application, that API, got removed. The next is kind of the length of the upgrades, especially in order to make them safe. They can take long, or they can be cumbersome to orchestrate all the process to make it very, very safe, or how these clusters can be very heterogeneous and have different applications and different teams within them that can have different skill sets. So again, some of them might have perfectly good availability constraints. Some might not have any. Applications might be legacy, or they might be net new, microservices architecture. And based on that, you can have different results. So in AKS, we did a lot of things to help with this. From PDB misconfigurations, we have deployment safeguards and draft that, as you saw before, can generate the deployments for you, including PDBs. We also, when we do the upgrade operation, we run pre-checks to ensure that everything is highly available. Second is having none of those, no health probes, etc. We have that in draft. It automatically gets health probes, basic ones, of course, to things like, is your port up and more, automatically. And then you can build up on those to make more more fancier and interesting health probes for specifically your application. Furthermore, for Kubernetes API breaking changes, and I'm super excited about the work we did there, we actually detect those now. So when you upgrade the control plane of AKS, we detect if any client anywhere is doing calls to an API that's going to be removed, and we prevent the upgrade from starting, giving you an error message that tells you you're using APIs that are going to be removed, and that will break once you do that. So the upgrades will never start if there's an API breaking change in that upgrade process. And then we have a lot of tools and controls for reducing the upgrade time and increasing the success, like max surge, drain timeout, max unavailable, soak time, which are things that you definitely can use in these type of heterogeneous clusters. But there's a few of these last two areas where we thought there's a lot more that we could do. Things are still a bit cumbersome and hard to orchestrate. So the first thing that we did was an improvement of the upgrade algorithm itself. Before, when you finish and when you're done doing an upgrade, all the nodes that are left behind that, for example, failed to drain because there's a PDB blocking it or some type of issue with that application that would violate its availability, so we don't finish draining and evicting those pods, they would just be staying there in the old version, and that's it. Again, if you own the cluster and the applications, that's typically not a problem either way, because you're gonna have to go yourself and fix it. But if you're in a platform team like Brendan mentioned, working for a lot of different application and developer teams, these might not be your applications. So now you can select a cordon and label facility instead that will leave these nodes behind, but cordon and label. So you can very easily finish the upgrade, actually, leaving, let's say, 3 nodes behind. But now you can look at that quarantine label to know which ones had not been upgraded, and then go and find the application teams that have those applications. They can then evict them or fix whatever was the problem that prevented them from evicted. And then they can use things like machine delete or just restart the upgrade to clean up those remainder nodes. The next is, okay, how do I make it safe without being very complex? And that is things like progressive upgrades. So there, Fleet Manager already supported the upgrade runs manually for you to configure, for example, different stages and upgrade groups, allowing you to have clusters in test, in dev, in QA, and in prod, and then for different groups, for example, different regions and different rings for your own upgrades. And now we're also supporting automatic upgrade within these fleet runs. So you're now able to set these up on your own maintenance schedule. They'll trigger automatically, follow your own stages that you defined, automatically wait between stages, and it will stop if one of these clusters in each stage or ring will ever fail. Let's take a look at how this actually works and how it leverages all the other AKS upgrade facilities that I just talked about. So in here we have a fleet that has 5 clusters. They're all in 1.28, potentially different patch versions of it. And they are fairly heterogeneous. They have different node pools with different images and more. So we're just going to configure one of our multi-cluster updates. We already have 2 stages configured, or 2 strategies configured. One is the staged one, the other one is a fast one. So this is a normal one that you see, which goes to Canary first, then APAC, and then Europe. And the fast one is essentially like a hotfix. So you might want to have a faster one available to you if you ever want to deploy things faster. So now we're going to configure this automatic upgrade profile that we're going to use as the stable Kubernetes upgrade. This will be the upgrade strategy that automatically will upgrade our clusters to the next stable version of Kubernetes, minor version. So we're in 1.28. It will upgrade us to 1.29 whenever we enable this. And this will run at our next maintenance window. So in here, we can check that our maintenance window has hit by TV magic, and one of these clusters is upgrading indeed. Now let's see what happens during this upgrade that's happening in Canary, where there's 2 clusters. One of these clusters is already upgrading, and again, from 128 to 129. Now here's a secret. There's actually breaking changes between 28 and 29. And one of them was actually in one of these clusters. So the upgrade actually stopped, even at the control plane upgrade itself, because there were breaking changes, namely on flow control. So these were detected in the last 12 hours by either a client, an application, or an operator, and the upgrade never starts. So this full set of upgrades never continue because our cluster in Canary failed the upgrade. It never even started in this case. Finally, backup. So we want to make sure that if anything goes wrong at any point, you have the ability to back up your solutions. And we have integrated with Azure Backup to create Azure Backup for AKS, which now, in general availability here at Ignite, allows you to fully restore clusters. Of course, the applications and persistent volumes as well, but full out clusters from one cluster to another, one subscription to another, and even one region to another as well in case of any failures. Let's now go and talk a bit about how we're doing effortless security. And Brendan's going to talk a bit about how we're making security not just providing more controls, but also making it a bit easier.
Cool. Thanks, George. All right. So we've had a whole big focus on security and the integration of security into DevOps. People have probably at this point heard the word DevSecOps. Maybe everyone's as sick of hearing it as hearing DevOps we got to be. But I wanted to talk about how we are providing comprehensive security for all aspects of the development lifecycle within Azure across a broad variety of teams. So this isn't just work that the Azure Kubernetes Service is doing. This is work that's integrating things all the way from GitHub all the way through to the Azure Container Registry. We have a bunch of things. I'm not going to drain this slide of all of the different features, but I am going to start working us through how some of these things work together. Specifically in the container and image, we want you to be able to understand the security and privacy requirements that you need to make to your application easily, so you can understand where are you at currently. So with Defender for Cloud Container Security, you can easily see where you stand in terms of vulnerabilities. You can have runtime protection to remediate those threats faster. You can have secure deployment with tools like Dependabot or GitHub Advanced Security, which are available to scan your code, scan for secrets in your code, scan for insecure algorithms within your code. And at this point, even actually provide automatic fixes for code problems that they find within your code. Defender for Cloud is actually built natively for Kubernetes. So it's not just like we're bolting on a bunch of pieces that didn't understand Cloud Native. We're actually attaching things that understand Kubernetes, can actually give you assessments associated with a pod. They can give you assessments associated with configurations of Kubernetes resources. And all of that helps you really understand what are the pieces that I need to do and what are the actions that I need to take. Like, for example, you might get flagged for a vulnerability in the underlying operating system that AKS has installed. Well, you could, in theory, I suppose, log on to that machine, run a package update, and fix that vulnerability. But that's not the right answer, and Defender for Cloud knows enough about AKS to say, actually, you should go use node upgrade or even turn on node auto upgrade in order to be able to sort of remediate this class of issue forever. And it's that kind of intelligence that makes things not just be notices, but actually very actionable and reduce the toil on your operators. Similarly, you can understand, is this a task for a cluster operator, or is this a task for a development application team? So we have this idea that we want to secure the posture of your application from build through to ship all the way to run. And then we have technology that can help you all the way along that way. It also helps to understand, because there's all sorts of different vulnerabilities, what specific things might be more important than others, right? What is the attack path that takes me from maybe an internet exposed endpoint through the Kubernetes service to a particular pod, back to a vulnerability that's in a container image that was derived from a Docker Hub container image, or whatever the path might be, to help you better understand and better prioritize where you need to focus your current security attention. Because of course we would love to be in a world where every single vulnerability is fixed immediately, and we continue to try and build the automation necessary to make that possible. But until that's there, prioritizing the efforts of your development teams to understand what is the real risk associated with a CVE versus a CVE that may not actually ever even be called. Those code paths may never be called in your application. Similarly, when we're thinking about container vulnerabilities, we're doing assessment all the way through the container development lifecycle. So we're assessing it in the Docker file itself. We're assessing it in the container registry across all of the different public container registries that are available, whether it's JFrog, other public cloud repositories, or anything that supports the container registry API. And then we're moving into AKS and discovering vulnerabilities in images, in node pools, and in clusters coming soon. All right, keep that animation going. And then we go back and enrich it with information that makes it more actionable. And then, of course, we have perspectives for all of the different owners who may care about the security profile of your application. If you're the CISO of a company, you care about more than Kubernetes. It's true, I know, but we want people to be able to see at a glance their entire security landscape if they're in the position to want to understand, is my company secure? But at the same time, if you're a development team, you don't want to see the security alerts that are associated with VMSSs that happen to be in an AKS cluster. You want to see those security alerts associated with the AKS cluster that you're using. And so we have different perspectives and different abilities for teams to be able to view their dashboards and understand what are the actions for them versus maybe what are the actions for another team. Especially if you're in a world of platform engineering, this is really useful to be able to differentiate between maybe cluster-level vulnerabilities and application-level vulnerabilities. And so I wanted to give you a demo of this, and I'm going to go over and do a live demo. So we will hope that we are, oh, and I have to actually plug it in because I was charging my computer. All right. Should have done that earlier. That's all right. All right, cool. Hopefully in a second. This worked last time. There we go. All right. A little bit of drama. All right, so this is the Microsoft Defender for Cloud overview. This is that CISO view that I was talking about. You can see here we've got 4 Azure subscriptions, 4 AWS accounts, 6 GCP projects, 5,000 assessed resources, and a bunch of attack paths. And you can see our security posture. We can see where we're at overall. So that's great if you're the CISO and you want to understand you want to understand the details of your overall perspective. But if you're the cluster owner, you might want to actually dive into a cluster itself. And in fact, you might not be thinking about security most of the time. You might be looking at your cluster. But of course, if you have Defender for Cloud attached to that cluster, you can go over here into the Microsoft Defender for Cloud, and you'll start seeing the things that are affiliated with your specific cluster. And you can see that they are sorted here by the criticality, but I can also see that this critical one is associated with a pod in a particular namespace with a particular image, and currently it's assigned to a particular owner. And so I can actually understand by clicking on it, I can actually see, all right, the reason that this is a high security or a high critical vulnerability is because of this specific package that has been installed. There's this CVE that's associated with it. And that helps me better understand, again, what is the possibility, what is the problem, and what do I need to remediate? And because I can have the namespace, again, the Kubernetes native integration of Microsoft Defender means if you're doing namespace as a service where different development teams have different namespaces, you can use this namespace information to route it to the right team for remediation. And you can even update the owner in line. And that integrates with Defender for Cloud's ability to have security pushes, effectively, where you can go and track the progress of all of your teams in remediating their security items. But of course, one of the things that I mentioned earlier that is pretty interesting is that attack path analysis. So if we go back to Microsoft Defender for Cloud, I can give you an example of this. So you can see here there's a whole bunch of attack paths. They're loading up. And I can actually go in and say, I want to add a filter. I'm going to filter for the resource type. And I'm going to say, show me all of the attack paths associated with a pod. I can apply that. And now we see some critical things associated with a pod. And we can actually click on this. And we can see the attack path analysis. So you can see I have the internet. It's connected to this service. That's a Kubernetes service, which routes traffic to this pod. And if I scroll across, hopefully if I know how to do this, you can say it's running in this pod is running with this container, which has this service account, which has permissions to this Kubernetes cluster, right? And so you can see from this attack path analysis that someone could potentially go from the internet all the way down into your Kubernetes API, working their way through that pod. And so this is really, really helpful to really understand not just, hey, there's some CVE, because there's lots and lots of CVEs out there, but actually to understand what should I do and which of them should I prioritize. All right, so we'll go back over to the main deck. And then I wanted to highlight another thing that we're really excited about, which is the image auto-patching in Container Registry. So with Container Registry now, and with an open source project called Project Copacetic, when you push an image into the Azure Container Registry, we will automatically detect and add a patch layer if you opt into auto-patching. And I might hear you saying, like, well, I don't want you to modify my image. And I will say, we don't actually modify your image. We add an additional tag, which is the patched image. It's -1 for the first patched image, -2 following semantic versioning. And we add a patch layer. So we take your entire image. We don't modify it at all. But we run patching on top, generate another layer for that container image, and put that container image layer on top so that any vulnerable packages that are in any of the bit layers of your container image, from the base image layer all the way up through your application layer, receive the patches, and those CVEs go away. And we don't just do that on push. We actually will do this regularly on a cadence. So once a week, or whatever interval you want, we will recheck the image when new vulnerabilities are discovered, and we will re-add a new patch with a new version. And so you automatically have an image with patches applied, but you have the ability to modify the Kubernetes YAML to deploy the new image on your cadence. And we will, in fact, actually send you a Dependabot alert. We've taught Dependabot enough that it will actually send you a PR. I'm going to actually skip through that, because just in the interest of time. The other thing that we've added is fine-grained repository permissions. This has been a request for a long time. We can grant Entra IDs specific permissions to specific registries. So that means you can, even though you have one container registry, at an image-by-image level, you can provide capabilities to pull down images. And that reduces the risks and the blast radius associated with having security problems in those images, from leaked secrets to everything else. All right, and then finally, when we think about the Kubernetes control plane and Kubernetes objects in the context of security, we're thinking about policy, and we're adding more and more built-in policies for securing Kubernetes. So you can enforce the shape of an AKS resource. You can turn on auto upgrade, for example. That's something that we're doing internally. And you can also manage policy for the Kubernetes clusters themselves, so that you can say things like, only pull from my private registry. And all of this comes together to ensure that your developers are doing things that are secure by default, and that they're literally blocked from doing things that would violate compliance or would violate the security posture that you want for your applications. And again, this is all based on open source technologies in Gatekeeper and beyond. And then on the node itself, we've restricted the IMDS service. So IMDS is a way of getting identity. Obviously, you want the pod to have an identity and not have it have the identity of the node. So you can actually block out access to the instance metadata service for your pods, which means they can't get tokens for that service identity. We've moved to having trusted launch available. This is a VM capability that makes it even more secure for the nodes that you're running on. We're setting seccomp defaults for your syscalls so that there's more security in the sandboxing of your pod to the underlying operating system. It's going to block dangerous syscalls that we know are used by people when they exploit vulnerabilities to jump into your pods. We're bringing out Azure Linux 3.0 on AKS, which brings in lots of new capabilities, minimal package sets, and of course, all of this is built by Microsoft so that we can respond immediately to security problems by rebuilding all of the Linux infrastructure that you're running on top of in AKS. And then finally, with the application and network, we're bringing in static egress gateway so that you'll know for sure where your IP addresses are coming from. And that helps you with firewalling and a bunch of other kinds of network security that you may need to apply. And we've also built out network isolated clusters so that you can create an AKS cluster that has absolutely no access to the external public internet. This has been a long-standing request from some very secure conscious people. And then finally, with the Azure Container Networking Services, we're bringing in a lot of network observability using eBPF. And in particular, from a security perspective, you can do FQDN-based filtering, which can allow you to restrict the kinds of traffic you'll allow out and into your cluster. And that's you. That's what I thought. All right, we'll hand back over with 4 minutes to spare.
So that's good, because this is about being efficient, the area of the deck where we need to be efficient, and we need to optimize, and we need to be cost conscious. So I think we'll do fine. So the first thing is, how do we think about it? And we think about it a little bit like from a FinOps perspective as well. Kind of skip the plan area here, because we really want to, as Brenda mentioned at the beginning, we want to think about being more automatic for your cost optimization itself. And so we're going to focus on these three kind of FinOps pillars of informing, which is providing visibility and awareness and monitoring and insights, optimizing, and then also reducing the operational complexity itself. So from an informing perspective, we have AKS cost analysis, which is an add-on that integrates with Azure Cost Management and allows you to have the cost for pods, namespaces, apply cross-charging, and have all the visibility that you might need. This is also built on open source, open cost kind of standards, and you can export this to other tools as well and integrate with other tools like KubeCost and more as well. OK, so now I see my cost, but how do I see where I can optimize? So you have in Azure Monitor a cluster optimization workbook that you can leverage. I find very, very useful, because it gives you kind of this heat map of where you're optimized and where you're not. So of course, red there means unoptimized. Maybe that pod has huge requests, but the usage is tiny. Or maybe the opposite is happening, and it's really going below past its requests, and it's always kind of hitting close to the limits. So you'll see that there in red, and you'll see it in green when things are pretty good. The requests and the usage is very on pair, and the limits are barely different in those cases. OK, so now you know which pods are optimized, which deployments are optimized, which ones are not. How do you know how to optimize them, right? So you know, sure, I get all these deployments are not optimized. What do I do? So you can use something like VPA to recommend you what are the kind of usage that you need to put in, what are the resources and limits that you need to throw in. And then you can have KDA or HPA to scale horizontally as well, so you can have maybe smaller replicas or a better use of the infrastructure itself. And speaking of infrastructure, we are GAing Node Auto Provisioning, which is the managed feature that is backed by open source Carpenter. In January, we're currently in kind of a freeze time for the holiday season, so all the releases are kind of finishing in January, and this is one of them. And this actually allows you to further bin pack the pods that you have across your cluster into cheaper, faster infrastructure during its consolidation periods. So rather than actually talking about it, let me quickly show it to you. And what we're doing here is we're going to have a Carpenter essentially provisioner. We're going to have on-demand and Spot with 3 different Azure families. And we're even using AMD as well for better cost savings, or we might have reserved instances there or additional prices. And then we have a deployment that has a weight of 100% for Spot and a weight of 50 for on-demand. So we'll prefer to be deployed on Spot, but then if Spot is not available, because maybe Spot is out, then it will defer to on-demand. And once we apply these two things, Carpenter will immediately just deploy Spot nodes until they're available. And if they lack availability or they're not there, or for whatever reason the price doesn't make sense, it will then start deploying on-demands from those 3 families. So you can very easily and granularly control that. You don't have to put sizes. You don't have to put node pools, and it does all of that for you. So with these 3 things, you can have the ability to have reduced operations, optimize deployments, and then have the full visibility across. There's one more thing, though, which is what if you're going across regions? And in that case, we also have now GA, the intelligent placement for Fleet Manager that allows you to deploy to not just the cheaper SKU and the cheaper node pool, but actually the cheapest region altogether from all your clusters. So you saw Fleet in action with those upgrades where you have multiple clusters. You can actually use Fleet to select which cluster you're going to deploy based on cost. All right, Brendan, tell us a bit what's next. 30 seconds.
In 30 seconds. So I think what's exciting about what's going forward is we're seeing automation come into all sorts of different places. From automation that's helping you do the right thing, directing traffic, directing your applications, to automation that's adding guardrails to make it easier for you to go fast without breaking things. And then finally, we're seeing with the connections to developer and developer productivity, as well as the AI that we're bringing in through GitHub Copilot and through Azure Copilot, that you can do even more than you ever thought possible with the Azure Kubernetes Service. Thank you so much. Hope you have a great Ignite, and we will check you out. Bye.